Okay, 60 runners start the race, and then one third, in the first half of the race, one third drop out. So in the first half of the race, one third drop out. That doesn't tell us how many, so we've got to figure out what one third, the first step would be to figure out what one third times, which is of 60. Okay? So first step is figure out one third, multiply one third times 60. And that will give us 60. 1 times 60 is 60. 3 times 1 is 3. So that gives us 20. So this is how many people dropped out. So how many are left? So 20 drop out. So that means we have 60 minus 20, or what? 40 runners remain. Right? Okay. Step 3. It says in the second half of the race, how many dropped out? 1/5. Right? 1/5 drop out. So then we have to figure out what is 1/5 times remaining runners, which would be what? 40 over 1. Why 40? Because that's how many remained after 20 dropped. Multiply tops. 1 times 40 is 40. Multiply the bottom. 5 times 1 is 5. 1 times 40. 5 times 1. That gives us 8. So how many remain? How many finished? Okay, so 40, and then 8 more drop out, and that gives us 32 runners who finished the race. Wasn't bad. So first we had to figure out what 1/3 of 60 was. That gave us 20. 20 minus 60 gave us the number remaining, and then we figured out 1/5 of those dropped out. That would be 8, and then 40 minus 8 gives us what? 32 runners that finished the what? Race. Very good. Okay, number 18. And number 18, we looked at, they discussed this integer concept here. And I want to show you what integers are. I like to tell you what integers are. Let me give you a list. I can't give you the whole list because it's infinite. But these are integers. Integers. So if our numbers look like this, when we simplify them, then they are integers. Whole numbers, you see, these are whole numbers. And I keep going. Yeah, I just wear myself out here. Keep on adding a number and keep on going here. That's what that ... means. And then what's the opposite of 1? Negative 1. Well, you know what's the opposite of a positive person? Negative person. So what's the opposite of a positive 1? A negative 1. And just keep on going. -2 and -3. And we just keep going, you see. So these are integers. If that number is a whole number or its opposite, then it is a what? Integer. Let's see. We have 6 of them to look at. The first one is A, and we're talking about 18A. It is -71.49. I can tell you, make a long story short, anytime you see a point anything, now this right here is an integer. The -71 is, but because that 0.49, it's not an integer. It's not going to be on this list. You see the pattern. So no, that's not an integer. B. 13 over 3. And that's a fraction. Let's divide it out. If we divide 3 into 13, we're going to get what? 4. You see, and 1 left over. So we took the bottom and divided it into the top. Came up with 4 with a remainder of 1. Anytime you have a remainder, it's not going to be an integer. So no, this is not an integer. 13 over 3 is not an integer. Okay? Let's look at a couple others. I'm going to erase some more down. I don't want to get too far down. Can't see there. So C, what is C? C is 15 over 3. 15 over 3. Well, let's go ahead and divide it out and see what happens. 3 goes with 15. 5 times 3 is what? 15. No remainder. So this is really nothing more than what? 5. Anytime you don't end up with a remainder, if there's no remainder, the answer is yes. That number, 15 over 3, is an integer. Because it's nothing more than 5. And 5 is an integer. Okay? So divide them out. If you get a remainder, not an integer. If there's no remainder, of course, it is an integer. Okay, the next one, D, is -99. Of course, -99 is an integer. It's the opposite of what? positive 99, which is a whole number. Certainly that is a integer. Yes, for negative 99. Okay. And two more. How about E, negative 30? Well, that's going to be a yes, right? And F, what is F? 5, of course, 5 is yes. Both of these are integers, negative 30 and 5, because the opposite of negative 30 is positive 30, the opposite of 5 is negative 5. It's a whole number. This is the opposite of a whole number, 30. Okay, hope that helped you out there. These are integers, these kind of numbers. 2.5 is not an integer. 7 over 6 is not an integer. Okay, all right. That does it for integers. Let's go to number 19. It's a rounding problem, and we want to round this number. Is that a rounding problem? No, actually you want to give the digits in the hundredths place and then 10,000ths place. So let's write this number down and name the digits that are in the positions they are asking us to do, to look at here. The number is 5, 7, 4, 3, 0, what? 2. Now remember the positions. Ones, tens, hundreds, thousands, 10,000s, what? 100,000s. And so we would see that A, the digits that's in the hundreds, thousands position, this is problem number, as we said, problem number 19. Let's make sure we keep the numbers up here. The hundreds, 100, what? Thousands. Position would be what? 5. And B, the 10,000s. 10,000s position. Not thousands, but thousands here. 10,000s position would be what? 7. Remember, ones multiply by 10. Hundreds multiply by 10. Tenths. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. Okay, remember the digit position values. Okay, number 20. Number 20 is a problem where we ask to subtract. We talked about this earlier. Subtraction here, number 20. We want to subtract. And the number is A, 10 minus 6. Remember we said this is subtraction, you know, because there's a minus between the two numbers. We said when you have a subtraction problem, write it as an addition problem by putting a plus after the first number. And this is read the opposite of a minus 6. So we said minus minus. Minus minus 6 is what? 6. So it's 10 plus 6, which gives us what? 16. Okay? And B, if you look at B, B is negative 5 minus a negative what? 2. Again, subtraction problem because of minus. So let's go ahead and write the first number down. Again, we're writing it as an addition problem by putting a plus after the first number. Always, always, always. And then continue to write the rest of the problem as you see it. Minus a minus what? 2. Please remember, just think about squeezing a little plus right here. That changes it from a subtraction problem to an addition problem. Now, from left to right, we have negative 5 plus minus minus 2 is what? 2. Remember we did that little drill? Minus minus 1 is 1. Minus minus 2 is 2. Minus minus 3 is 3. When I see minus minus 4, I put 4. So we see minus minus 2 here, and I put 2. We're adding numbers with different signs. Remember I said about adding numbers with different signs. Take the sign of the largest minus. Then subtract them. 5 minus 3, 2 is a what? 3. Or I have more negative numbers than I have positive numbers, so that makes the sign negative, and then we subtract. Either one of those, very, very sound approaches. You'll always get the right answer. Okay, let's look at number 21. We're getting there. Boy, we're getting there. And I hope this is going to help you as you're viewing it. It kind of gives you a little bit of better understanding of that review that was emailed to you. So let's look at number 21 here. 21, we're asked to evaluate. It says evaluate when x is 5 and y is 6, negative x plus 9y. Let's take a look at it. It says when x equals what? 5 and what? Y equals what? Negative what? 6. So this is going to give us, remember what we do here, and what's the expression? We have to have an expression. We need to figure out what this is going to be. In other words, what is negative x plus 9y? So that says when I put the number in for x and I put that number in for y and work it out, what do I get? So let's do that. This minus is already here. It says put 5 there. Okay. Plus 9 times y is negative what? 6. Okay. Now what do we do? Remember the order of operations. You don't do the addition left, right. Addition is the last thing you do when you have multiple operations. So we do the what? Multiplication first. Multiplication always comes before addition and subtraction. This, from our signs, positive times a negative gives us a negative. Bring down the rest of the problem very carefully. Now what are we doing here? It looks like I'm add. Same signs. So we keep the sign and add. Remember we talked about that. When you add the same signs, you keep that same sign and add the numbers and get negative what? 59. Remember, whenever you see this, 9y means 9 times y. So, very, very important to this problem. Okay. The next problem is actually a question where they asked us to, we saw this earlier too when we looked at the runner's problem. And it comes back again, just what is 1/3 of 18? Of means multiply. This means multiply, so this is 1/3 times what? 18 over 1, which gives you 18 over what? 3. Where did this come from? 1 times 18 is 18. 3 times 1 is what? 3. Put this in your calculator as you see it. 18 divided by 3. Exactly the way it says it. 18 divided by 3 is going to give us what? 6. That's good. All right. Of means what? Multiply. Don't forget that. Multiply numerators and denominators and then divide. Okay. That's how we got that answer. Okay. Now, we have another equation, another multiplication to do. Number 23 says to multiply 3/4 times 24. 3/4 times what? 24. Well, we write this as 3/4 times 24 over what? 1. Okay? And what can we do? We have several options. We can cross cancel here, but I'll go ahead and do it the long way. 3 times 24 is 72. 3 times 24 is 72. 4 times 1 is what? 4. In your calculators, you can put it in just as you see it. 72, punch that, and hit the dividing button, and hit 4. And you'll come up with 18. Oh, it's pretty good. We don't come up with 18 every time we multiply, guys. A fraction times a whole number is just coincidental that we came with 18 for both problems. Solutions for both problems. Okay, 24. We're almost there, guys. Hold on. 24 is another equation. And we want to solve. The equation is 7 over 3 x equals what? 42. Well, we're asking What number can I multiply by 7/3 and get 42? Well, we'll find out what that is. Here we want to get rid of the fractions. So my LCD is what? 3. So I'm going to multiply everything by 3 to eliminate that fraction. I want to eliminate that denominator of 3. So I multiply by 3. If this denominator was 6, I'd be multiplying both sides by 6. If this was a 5, I'd multiply this by 5 and multiply this by 5 instead of 3 and 3. Okay? What's going to happen? 3 goes in 3 one time. 3 goes in 3 what? One time. 1 times 7 times x gives me 7x. Over here I'm going to get 120 what? 6. This means 7 times x equals 126. Divide both sides by 7 and we'll end up with an answer of, I hate to say it again guys, 18. And I know it's coincidental. We don't always get what? 18. And really we should write it here. X equals what? 18. I wrote it over there in case you are not able to see my last line in the video. How do we get this? Remember the 7's cancel out. We get X. Okay. All right. Very good. Okay guys, we've come to the grand finale. The last problem on the review. And I know you looked at that thing and probably thought it looked a little wicked. It is a little complex. Well, yeah, I remember when I first looked at it as a student for the first time. It was a little complex. But we're going to clean it up. It actually is called a complex fraction. Let me show you. So what we want to do here is simplify this thing. And it's not bad. Let me see if I can bring it to you here so you understand it. 3 over 8 minus 1 over what? 7 over 4 plus 1. Okay. This is my least common denominator. Look at your denominators of 4 and 8. The least common denominator is what? 8. The least common denominator is 8. Okay? Why? Because 4 go into 8 and 8 will go into 8. So the LCD is what? 8. Okay? And I show you how you can find that LCD. You can do it this way if you want. 4. How about 8s? 4. How about 4s? 8. 12. And for 8 we have what? 8 times 1 is 8. 8 times 2 is 16. We're just counting by 8s. And this will be 24. You see anything that's common? Oh yeah, for 4 and 8 they have a common multiple of what? 8. So that's our least common what? Denominator. That's how we get that. So what am I going to do with this 8? Multiply each one of these by 8. Okay? And then what's going to happen, this is going to cancel. 8 goes into 8 one time, 8 goes into 8 one time. But 4 goes into 4 one time, and 4 goes into 8 what? Twice. Okay? 8 goes into 8. 8's cancel. Both of them 8, so they cancel. But here, 4 goes into 4 one time, and 4 goes into 8 what? Twice. So what we're going to do here is get 3. That's all we have left here. Minus, this is multiplication here. Negative 8 times 1 gives us a minus 8. And then 2 times 7. 2 times 7 gives us what? 14. And plus 8 times 1 is 8. If we add that up, we get negative 5 over what? 22. From our tables, we talked about what do we have in terms of sign when we divide a negative by a positive number. That makes the whole fraction what? Negative. So the answer to that is negative 5 22nds. That negative is in front of the fraction. So we want to note that. So we've gone over all 25 of those problems that were on the review. We hope that it's going to be helpful to you, that you benefit from it tremendously. You can use your books, open book, open notes. We wish you much success on this midterm exam, and we hope that you get them all right. But do the best you can.